Alright, so I think I'm recording. We are taking a look at skill packet 3, which is relations and functions. And in 3E, they're asking us to take two functions and use them to build a new function, and then also to find the domain of this new function. Alright, so let's add these together. So we'll create this new function that they're calling f plus g of x by simply adding f and g together. Now this time, in order to add two fractions together, they have to have a common denominator. So I need to multiply this first one by the number 1, but I need to write 1 in such a way that it will give me the same denominator as the second fraction. So you can see that I have x minus 4 times x plus 4, and here the same, just the order is reversed. So since I now have a common denominator, I can write these two fractions as a single fraction with this denominator of x minus 4 times x plus 4. In this operation of addition, I can add this numerator and this numerator together. So in the first numerator here, I need to distribute this 3 and get 3x plus 12. And in the second numerator over here, distribute the x and get x squared minus 4x. So I have x squared minus x plus 12 all over x minus 4 and x plus 4. Now, you can't factor this top fraction here because you can't find two negative numbers that multiply together to give you positive 12 but add together to give you negative 1. If it were possible for me to factor it, I would, just to see if there's any common factors that would cancel, but in this case there's not. So in part A, this is my answer for f plus g. Was that part A? Yeah, f plus g. Now for f minus g, the work looks very similar. I'm also going to paste it. There it is. So the work looks very similar, but now in this time, we don't want addition. We want subtraction. But we still need the same common denominator. And the big difference here, when I subtract, when you're subtracting this second binomial, you're subtracting both terms, not just the first term. So without these parentheses, you're very likely to make a sign error. So my denominator is the same. But now when I combine these like terms, the subtracting the negative 4x is 4x plus 3x gives me 7x and then plus 12. So again, I don't see how I can factor that numerator. Now, just in case I'm not looking at it right, I'm going to factor a negative 1 out. I'm so used to seeing the leading coefficients being positive. Yeah, I'm looking for two numbers that when multiplied together give me negative 12, and yet when added give me negative 7. Well, the closest I can really come to that, if I try a negative 4 and positive 3, they're going to add to negative 1. If I try a negative 12 and a positive 1, it's going to add to negative 11. I really can't find any that add up to negative 7, so I'm going to leave my answer. I don't know how that... Okay, up at the top here when I shrunk it, it got a little bit messed up there. But this is my final answer. You can look back in the video and if you need to see the work above. So be careful up here when I shrunk it. I can see that it didn't grab everything and didn't shrink everything together. It left some things there. All right, so oops. All right, so that was f minus g. What does it want next? It wants g plus f, which is the same as answer A. So here in A, this is also equal to f plus g of x is the same function as g plus f of x. So this answer that we had for part A is the same for, what was it, part C? Yeah. And the B and D, the answers are going to be opposite, equal in magnitude, but opposite in sign. So let's go get our answer in B, which was here. Which it's pretty easy then to take the opposite, because remember I factored out that negative sign, so that's going to make it really easy. So it wanted g minus f this time. It wants g minus f, which is the opposite of f minus g. So all I have to do is take, if I take the opposite of that negative, is boom, and here's my answer. Okay. Now it wants me to find the domain of all of those. Well, the domain of all of those are all going to be the same. To add, subtract, or multiply two functions together, that result will always have this. It's only division that may result in a new function that has a domain that's different. So to find my domain of f plus g or f minus g or g minus f or g plus f, I'm going to intersect these two domains. So I need to pause this for a minute. Alright, so I'm back. The domain of any function is the set of all real numbers, excluding any values of x that cause division by 0, and also excluding any values of x that cause us to take an even root of a negative number. Well, we don't have any square roots, so we do have variables in the denominator here. So if I'm trying to find the domain of f, I just have to make sure that x minus 4 is never equal to 0. I have to avoid letting x be 4 because 4 minus 4 gives me a 0 in the denominator. Any other number is fine. You plug it in and you get a related y value. For over here, x plus 4, if we set it equal to 0, we can see that negative 4 is a solution to that equation. We don't want that. We do not want that denominator to ever equal 0. So my domain, if I draw I suggest that you draw your domains on a number line when you're finding the intersection, because when I'm trying to find the domain of f plus g or f minus g or f times g, we intersect these domains, and it's a lot easier for students when they're beginning this process to draw them on top of each other and then intersect the two to look and see what's in both. So negative 4 and positive 4 are the two values of interest, and I don't have to sit here and go negative 3, negative 2, negative 1, 0, 1, 2, 3, you know. I know that negative 4 is less than positive 4 because I'm just using this as a, not to illustrate my final answer, but just to, as a sketch to help me write my final answer. Alright. So in our final answer here, in order to be in our final answer, you have to be in both sets. So the top set here, the domain of f, was all real numbers except positive 4. So we circle positive 4, but all of these other numbers are in the domain of f. And in the domain, in the domain of g, we want to exclude a negative 4, but all of these other numbers are in the domain of g. So we can look and see that negative 4 is not in both domains. It's in the top one, but it's not in this one. Therefore, it can't be in my answer because it has to be in both to be in my answer. Positive 4 is not in both, so it's not in my answer. But to the left of negative 4 is shaded in both. And in between is shaded in both. And to the right is shaded in both. So our answer for part A and part B, that finding the domain of each of these, well, in problem 3, they're all going to have the same domain. And that's from negative infinity to negative 4, from negative 4 to positive 4, and from 4 to infinity. Alright, so I'll do this next one in another video. Let's make sure I answered all of those. So we found f plus g, didn't we? Well, wait a minute, did I? Yeah, I thought I found. Yeah. I'm forgetting what I did. Alright, so I hope that helps.